Hi there, welcome back. In this video, we're going to cover doing a structural analysis with Altair Inspire. And to do that, of course, I need to get some geometry in here. I'm going to come up here to File, Open, and I'm going to open up this parasolid file. This is one of our standard files from our class. And I get the file in here like this. So I'm going to just take a quick look around at it. Once I have it in there, I can do things like measure. If I want to measure a specific distance, I can click on that and click 2 points and it will provide me that distance, or I can grab this box here, click the part, and it will create a bounding box and give me the overall dimensions for that box. So I can get an idea of what the size of my part is. To get out of any function within Inspire, you just simply right click and then take your mouse and just pass it through this little checkbox and you'll exit the function. Now, if I come over here, you see my measurement is saved. I'm just going to right click on this and delete it because I don't need that measurement anymore. But I'll take a look at my part, and you'll see my part says it's 9.4041 pounds. How does it know that? Well, Inspire is going to automatically assign a material to that. And the material by default that it assigns is the material at the very top of our material library, which is steel AISI 304. And we automatically assign a material, so we can guarantee that everything is analytical. But one of the first things I want to do when I do an analysis is to make sure that I assign an appropriate material. This part happens to be an aircraft door hinge bracket. And so I'm going to make this out of aluminum. To change the material, I can do that a couple of different ways. I can come here to the part and select from my list here. My personal favorite way of doing it is just to right click on the part and come here and select material. And when I come down here, I can see a list of all of these different materials, all the way from steel, ASA 304, all the way down through plastic nylon. These are materials that are included in the software in our material library. And from there, I can select aluminum 7075 T6. And as soon as I select that, you see my model automatically adjusts here. It has now recomputed the mass of the part, or the weight of the part in this case. But you may have noticed down at the bottom here, and I didn't include it, I've actually have a material called Douglas fir. I was doing some work on a part that I wanted made out of wood. So this is a custom material that I defined. It's very easy to add a material to Inspire. I just come to my structure tab here, my structure ribbon. And I'm going to come to materials. And once I do that, it's going to open this up. I've got 3 different tabs here. The first one is parts. It's going to list all of the parts in my model and their associated material. I only have the one part, and its material, of course, is 7075 T6 aluminum. Material library allows me to see all of the materials that are in my library currently and their definitions. And then my materials is where I can add my own materials. You see my Douglas fir there, but I can click the plus and we'll add special material here. It defaults to material 1, but I can come here and click on that and rename that to whatever I want. So we'll call it something unique. Erik's material. There we go. And now I just need to enter the values for that material. As Inspire is a linear static analysis, we do require it be a linear material. So we're going to deal strictly within the linear range of the material, which means we're going to define the strength of it by the Young's modulus, the Poisson's ratio, and then we ask for the density so the mass can be calculated, the yield stress for analysis purposes, and then coefficient of thermal expansion, which is used if we're going to be using heat as a load. Right now, the material does have to be isotropic, homogeneous material. So fortunately, we can't, as of yet, support non-isotropic materials, composites, that sort of stuff. That isn't to say people aren't doing analysis on composites using Inspire, but they're kind of homogenizing the material, taking the entire layup and coming up with an equivalent material specification. You'll also notice here that the material, my Young's modulus, which of course is a pressure, is being referenced in pounds force per square inch. That's being defined down here by my units. And units customarily have always been kind of a difficult thing when it comes to analysis. We've tried to make them as easy and seamless as possible within Inspire. All you have to do is come down here to the units, click on that, and you'll see a list of all of the common units there. We even allow you to customize units. But say I don't want to do it in inch pounds force, I can come up here to MPa, which is millimeter Newton second. I click that, and you see automatically my specifications have all adjusted to that new unit scheme. And in fact, if I come to my part here and I take that same measurement that I had before, you can see now it's showing it as 70 millimeters. The great thing about units within Inspire is they are entirely seamless. I can switch units at any point in time, countless times through working on the model, setting it up, analyzing it, post-processing it, and nothing happens to the model other than it adjusts to the new units. All forces, all measurements, all material definitions will automatically update to the new units. So I don't have to worry about messing up my model. I can now just reference it in the new unit scheme. So units are truly seamless within Inspire. Now I could delete that measurement, or as with pretty much everything with Inspire, it does have a display state, so I can click that and turn it off, and that still exists. It's just not being shown anymore. So now I've defined my material, and you can see now it's being shown in metric tons, so it's a very small number. Let me switch it back to English units here. So 3.2914 pounds. So I want to run an analysis on this. I want to do a relatively simple structural analysis. To be able to do this, I need to constrain it somehow or hold it in place. So I'm going to come back to my structure, come to my loads icon, which has a number of multifunction selections on it. And down here at the bottom, we have the supports. You'll notice that the icons within Inspire, they're large, they're somewhat colorful, and they're very descriptive as to what they do. And we were able to achieve that by combining functions through this multifunction idea. And you can see my supports here are supporting this little block, so you can see what they're meant for. And when I select that, my pointer gets a little support modifier on it. And now I can select either a point, an edge, a face, or a hole. If I select a face, doesn't matter where I click on the face, the icon will appear wherever I clicked, but the fact that the entire face turns red is what's important to me. It means that this entire face is being held in place with an encastra constraint. There are times, though, where I don't want to fully hold something in place. I want to free up a direction or two. So I can just double click on that. And now you'll see I get these little pointers here. If I select one of them, it turns green. And now when I right click to get out of this edit, my icon has modified to include these roller wheels. The roller wheels will show me the direction that it is now free to move. So it is now free to move in what amounts to, what's that? Looks like the x-axis there. So now free to move in the x-axis. So these rollers are actually pointing in the direction to the point that I can even come here and double click on this and select this little move support. I get my little triad with my spinners and translation. And if I take and I spin that, I can spin it manually 5 degrees at a time, or I can type in a value here. And now I'm 40 degrees off of the x-axis. And my little rollers are now pointing in that direction. So it truly is showing me the direction that is freed up in. If I double click on it again, I can select this one, and now I get a little caster ball showing that this is now constrained in plane, but it can freely move in the plane. And then if I were to select the third one, it goes to a faded view because that is no longer doing anything. And I can turn those back off again, and now I've got a fully encastra constraint. In this case, though, I don't want to constrain that face. What I actually want to constrain are these bolt holes down here. So this bracket is mounted onto the aircraft like this, and the door hinge goes through here. So I'm going to simulate it mounting onto the aircraft by constraining these holes. So I'll come back to my constraint, select my hole, and I get a different looking constraint because Inspire does recognize that this is a hole and recognizes that when it comes to holes, they have some unique features when it comes to constraining things, because most of the time, When we're constraining at a hole, we're putting a bolt through there or a pin through there. So now if I double click this, I get slightly different features that I can free up. I get this kind of partial circle going around there, which if I select that, it turns green. And now that's saying that this part can rotate around the axis or move up and down or along the axis, but it will always be constrained normal to the axis, so acting like a bolt or a pin is in there. Now, as a little trick here, I'm going to create actually all 6 of these, but if I want to modify a constraint, if I create one and then modify it, and then while I'm still in the constraint function and come through here and let me try that one more time. There we go. And now come through and select them, and it's not working the way that I wanted it to. Okay, well, hey, sometimes even in demonstrations, things don't work quite the way we wanted them to, but that's okay. So now I've created the constraints here. I actually didn't even want these freed up like that. I did want them fully constrained. But in the past, it has copied that. Maybe that is a feature that's no longer there, but that's okay. So I now have my constraints in there. The part is held in place, and the next thing I want to do is go and add a force to it. So I'm going to come here. I'm going to select my force. And again, I can put a force on an edge, a face, or a hole, or a point. If I select a face again, you see it says 1 pound force, and again, that entire face is highlighted in red, and thus that means that this 1 pound force is going to be evenly distributed across that entire face. If I want to change it, I could say 100, and now 100 pounds force. And you'll see when I come here and I highlight this, it tells me force 1 equals 100 pounds force, and then it even tells me what the equivalent pressure would be based upon the area of the face that it's applied to. So I don't have to worry about the placement on it. I just click on it, and I can get an even dispersal and an even spreading of that force across that entire feature. And that works also with lines. Points, of course, it doesn't spread it. It's just a point load, but it would on a line. Or on a hole, if I come here and I apply it to the hole, which is what I want to actually do. So I'm going to select that hole right there. It is now going to connect that to the entire inner cylinder of that hole. And whatever direction I select here, either X, Y, or Z, it will point in that direction, and then I can do plus or minus. And just like I could with my constraints, I can come here and I can manipulate the direction of that with my little manipulators here. Or if I happen to know the vector components of my force, I can put those in here. You'll see these are the components of a unit vector. That does not have to be in unit vector form. I could say 3, 4, 5, and that will work perfectly fine. And that does not affect the magnitude. These are independent. This is just a direction vector, and I can specify the magnitude there. Now here's a nifty thing. Let me first of all put this in the direction that I want. We'll put it in the x-axis. Nope, sorry. Let's put it in the y-axis negative. There we go. So right now it's 100 pounds force. And if I were to type in, say, 2,000, it would be 2,000 pounds force. But say, for instance, I happen to know that 2,000 newtons of force are being applied to this. And I don't have my calculator handy to do a quick conversion on it. I can type in 2,000, and as we just saw, if I clicked enter, it would be 2,000 pounds force. But if I type the unit abbreviation N for newtons and click enter, it automatically updates that to whatever unit scheme or unit system I'm in. So I can even enter values in another unit system and it will automatically convert them as long as I include the abbreviation for that. Now I want another situation here. I want to study something else. So I'm going to put another force in here. and we'll have this one act in we'll act it in the z-axis, and we'll make this I don't know, 300 pounds force. Really doesn't matter what the value I put in there right now. Of course, I would want to know exactly what the values are for my load when I set up my analysis, but we're just doing a quick study here of how to set it up. So now I've got these two forces. I have the 449-pound force acting this way, a 300-pound force acting up. The problem that I have is both of those forces are going to act together. And I want to make sure that these are two different scenarios that I'm studying. So I can come up here, and if I highlight my force or my load icon again, I get this list load cases. I can come here, and you'll see we have all of these different load cases here. I can add a new one, and then I just kind of pick buffet style what I want from there. So we'll say this one will be force 3, this will be force 2, and now I have two entirely separate load cases. I'll get results for both of them, and they'll be run separately, but they'll run together in my analysis. I'll just get separate results for each of them, so I don't have to run two analyses. And I can add as many of these as I want. So let's say, for instance, I want to simulate bolt 2 and 3 failing, so I'll just select the rest of these and force 3. Or I could say, wow, it's a particularly hot day, and I'll apply a temperature load on here. And we'll say, 100 degrees Fahrenheit. That is a delta T. So it doesn't matter what the temperature is it starts with, it's just going to deform based upon that delta T. And now I can add another one. So we'll say all the constraints are working, this force and this temperature, and now I have 4 different scenarios that I'm running. And I can come here and rename these to whatever I want to make them a little more logical when I post-process. Additionally, I can do enforce displacements. So I can say move this point, whatever it takes, move this point 5 millimeters, and see the stresses as a result of that. I can do gravity loading. I can do angular velocity and acceleration. I can set gravity, so if I want to include gravity in my analysis or do G loading, I can set the direction and the acceleration for gravity. I can even add non-structural masses. So say I wanted to analyze this with something hanging off of there. I didn't know the force. I could put a mass on here, specify the mass of that, and then I would just set the center of gravity of that mass. And it will move that mass to that center of gravity. And then I click this and I can attach it to my part, and now I have a mass hanging there, and it would analyze it as if this non-structural mass were hanging there. So I have pretty much just about every way I could possibly want to analyze this, and I can get the results that I'm looking for. So I'm ready to analyze this. Everything is set up fine. I just come to my Analyze button. We'll talk more about some of these other features here, normal and buckling modes, in another video. Right now, I want my result to be as accurate as possible, so I'm going to leave that. I'm going to leave my contacts alone. We'll talk about contacts in another video. Whether I want to incorporate gravity into my analysis or not, in this case, I'm going to leave it off. I don't need gravity. This is a relatively compact part. It's not going to have gravitational effects on it. And then I'll just click Run. Now this analysis will take just a couple of minutes here. It should run relatively quickly, and we'll pick it up once it gets done. So that took just about 2 or 3 minutes to run, and you can see as soon as it's done, we're treated with this little green flag above the Analyze button. And when I click that, it takes me automatically into the post-processing. Now we'll get into some of the more advanced features of post-processing right now. So we'll just take a quick look at the animation. We can see the behavior of that, and we can take a look at each one of the different load cases here, so we can see the different behaviors. So this is the one that's growing with the temperature. We can indicate what we want to see. So I'm going to come down here. Right now I'm seeing displacement. Now these displacements these values are actually correct. So these are the correct values. Our animation is very much exaggerated. If I come here to my displacement scale factor, you can see it's being exaggerated by 94 times. If I come down here and select 1, you see you really can't even see anything at all. In fact, I gotta really zoom in there to begin to see any sort of motion whatsoever. So we automatically scale that up for you so you can see the general behavior of it, but it's very easy to bring it back to a one-time scale if you want. Come back down here, I can take a look at my von Mises stress in all of the different load cases. See, there's not a lot of stress there. And then take a look at something like factor of safety. So we'll have an entire video on some of the features and the advanced features within the post-processing. But that's a real quick video showing you how to set up, run, and post-process a quick structural analysis within Inspire. Look for more videos covering some more features, and thanks for watching.